Okay. So I kind of just mentioned that Unit 1 is 11 days. The good news for us is we're actually a day ahead. So yesterday, when I talked quite a bit about discontinuities, I think it took over an hour, if I remember it. That actually covered yesterday and today. So today, if you look at Khan Academy's, or what I put in Schoology, right? What I put in Schoology for Khan Academy is continuity over an interval, which we definitely kind of discussed when I was putting up different piece functions, things like that. And then the other part is just removable discontinuities. Now, referring to a removable discontinuity just means that a factor cancels. And so, in Khan Academy's layout, they kind of have that separate than normal discontinuities. And so we've actually already covered all of it. And I thought what would work better is rather than just like giving you a day off today and then tomorrow going immediately back to like trying to lecture for, teach you stuff for over an hour, is I thought I would split up and start teaching tomorrow's a little bit today. And so we'll have a very short lesson today and a very short lesson tomorrow. And then that way you guys should have plenty of time to try to do some work and catch up on things if you're feeling behind. Now, what I really want to emphasize to you guys is it feels like, how should I say it? I haven't had a single person come into my open help sessions yet. And if that's because you feel like it's going really well for you right now, that's awesome. Like I don't have a problem with that. It's also hard for me to gauge how you feel it's going for you, because you guys aren't very good at saying anything during the class hour. Everybody just stares at the screen. And I get that it feels awkward to speak out loud in the classroom. Maybe if you're at home, obviously it should feel a little easier to talk out loud. But I'm hoping you guys kind of get past the awkwardness of being in the classroom and it just being quiet all around you. Because the learning and the experience goes a lot better for you if you kind of participate. Even if you're having a really hard time with the material, just participating makes it feel less stressful, makes it feel less anxious. And so I'm sure you guys realize by now that this class is 100% an emotional roller coaster for you. Like, this is the easy chapter right now, right? And so as we get through the different chapters, there's going to be times where it feels like it gets really hard. And then there's going to be times where it feels like it gets really easy. And I called this the easy chapter. I'm not trying to say that it should be going easy for you. I say it's because it's the beginning of the book. It's going to feel, difficult the whole year. But it would be a lot better if you guys participated. And so when you guys need help, make sure you're getting help. And I'm okay if you're doing that with another student, like a friend, something like that. But I really haven't had anybody message me with questions or come into open help times and ask questions. So hopefully you guys start making use of that. And if it feels like it's going really well right now, that's good. I'm going to start getting in contact with people who are behind, because there's quite a few people who are like at 10, 20, 30% in Khan Academy right now. And this Friday, is when you should be done with Khan Academy for Unit 1. So by Thursday night, you should be, the highest you should be at is 80%. Because the way Khan Academy lays it out is really goofy. They call it mastery, okay? And so if you do something the first or second time, you know it really well, but you haven't mastered the topic yet. So in their scoring system, you can earn up to 80% if you get if you get everything correct all the way up to the end of the unit, you'll be at 80%. And then when you take the end of unit test in Khan Academy, that's how you earn mastery status or level. So basically, if you get a question correct on the test that ties into the first two topics, then those first two topics bump up to 100%. That's how they use the end of unit tests in Khan Academy. So by Friday night, or I guess I should say Sunday night, you guys should be fully done with Khan Academy for Unit 1. And there's a lot of people that aren't at that level yet. They're not even close. So today I'll start getting a hold of you guys. And that's why I wanted to do a short lesson today and a short lesson tomorrow to kind of be able to, let some of you ask questions and catch up. So let's start doing infinite limits. So this is the topic for tomorrow. And the first part of this, I'll draw a graph. Because there's infinite limits is broken up into two pieces. It's broken up into graphs and equations, or analytical. And let's say we have you know what? I am actually fully impressed with that line I just made. That dotted line came out so much better than I expected. I don't know. I should probably quit for the day. I definitely should quit for the day. This came out good. That normally doesn't happen. Let's go with Jessica Telstad. Jessica, you ready to be our professional answerer? Okay, so that laugh tells me that you're not. But do you remember what I tried to tell us when we first started the unit? What is a limit? Perfect. That's a great way of saying it. So it's technically when the values converge from left and right, but what you said is perfect. So if we're looking at this picture right here, both lines are shooting straight up. And it's never going to be able to converge. I guess, I was going to ask you another question, but I'll hold off on it for now, Jessica. You did great on your answer. Infinite limits is considered a separate part of the unit because the answers technically aren't real. Okay? So I didn't even assign a number to this. Let's say this is x is 2. That was a horrendous x. Let's say this is x equals 2. If I ask you to find the limit as x approaches 2 from the left, and the limit as x approaches 2 from the right, these are considered special because the answers are going to be some sort of infinity. And infinity isn't converging, like it's not stopping or turning into a number. So it's not a real answer, but by the fact that us answering infinity, we're basically saying that we know what's happening, and then it's different. So on the left-hand side of 2, it's pointing straight up. Okay? So that's the left-hand side of 2. And since it's pointing straight up, that answer would be positive infinity. On the right-hand side of 2, this example is also pointing straight up. So that answer would also be positive infinity. because that's where it's headed. It's going up. Now, if it was pointing down, we would say negative infinity, because down would be, that's the height. Negative infinity would be if it was pointing down. If you were asked, come on, pen, there we go. If you were asked to find the two-sided limit, well, automatically we find the answer from the left and from the right to figure it out. And on this one, you could answer it kind of two ways. Because these matched, we could say it's infinity, or there is no limit, like doesn't exist. On the AP test, they usually will have these grouped together. Like it'll say, does not exist, comma, infinity. Because infinity isn't an actual answer. So usually you just write both to show that you understand that. But I'm not going to be that picky on it. I'm okay with you just answering infinity because these two are the same. Go ahead, Isabella. Or did you have a question? Oh, yeah. Yeah, that's the math symbol for does not exist. You can write DNE, like I'm sure a lot of you used to write DNE, that's fine. Okay, well, I didn't want to spend most of our time on pictures because it's usually pretty straightforward when you're looking at a picture. If it's pointing up, it's infinity. If it's pointing down, it's negative infinity. And that's kind of it. What I wanted to focus on is when you have equations and you do not have a picture. So, who should we go with? Caden Kirsch. We'll go with you. Or was yours the mic that was goofy? I don't remember. No, it's working fine today. That's weird. Gotta love a Chromebook. Oh, yes. That the microphones in earbuds sometimes don't work well with Google Meet. I've kind of found that out. I had a couple days first tech semester where I sounded like a chipmunk, like from Melvin and the Chipmunks, and it just for random times. Well, here's your question. No, I'll make it a 1 to make it easier. What happens when you have a regular number on top, but a really tiny number on bottom? Nope. 1 divided by 1/1000th. I know that was your question. Or, good. Yep. It's basically like saying if the top number is really big compared to the bottom number. Because division means how many times would I add the bottom number to get to the top. Well, if I make the bottom number even smaller, let's see, what tenths, hundredths, thousandths. I'm already totally messing myself up. Is that the millionths? Probably. Too many numbers and my eyes start to lose it. Okay, so here, Caden, I was going to give you the challenge question. Do you remember what the plus symbol means? Like that 0 plus? Kind of. We're not doing a limit, though. So the plus technically means the right side. That's fine. How much bigger? Are you talking about scientific notation? Oh, no, that's all right. That's all right. I don't mean scientific notation, no. Does anybody else know what I'm trying to get at without me just giving the answer? I mean, you did good, Kate. You did good. This is a difficult question. So the plus symbol means just on the right-hand side of 0. So it's as close to 0 as you can get, but just barely bigger. The word they use is infinitesimally small. That's the wording they use. So I wrote some small decimals over here, right? So 1/1000th, 1/1,000,000th. 0 plus is supposed to be the smallest one of all, the smallest one possible. Does anybody know what the answer over here would be? Zero plus is supposed to be a lot smaller than whatever is up here. What happens if this answer gets a lot bigger? Infinity. Yeah. Maybe infinity. So this isn't like, how should I say this? This isn't real math. This is what I'll describe as fuzzy math. That's how I was described it in college. So this was part of the discrete math class that I took. And it's more about you just knowing the answers rather than like proving it. Okay? So if I know that the bottom number is a lot smaller than the top, I know the answer is going to be infinity. What would 1/0 minus be? So the minus means it's barely to the left of 0. So that would make it negative 0.00000001. So positive 1 on top divided by a negative, ridiculously small decimal would give me negative infinity. So I know some people hate this because it's not like, you can't type it in your calculator. Like, you can try, but it just doesn't work. This is called discrete math because it's ideas rather than rock solid numbers. Okay, the whole reason I'm showing this to you is because that's what you're going to have to use to find these answers that are going to be infinity. So let me put up example 1. If you have f of x equals -1, you know what? I'm not going to do -1. Let's do +1 to keep things simple for you. 1/x minus 1. Our question is going to be to find the limit of the function as x approaches 1 minus. Let's do a one-sided limit. Instead of doing a two-sided limit, we'll do a one-sided limit to make it more straightforward. Lucas, what's the very first thing we do when we try to find limits? Do you remember the kind of order? That would be if we do a two-sided limit. So if this little minus sign wasn't here, then we would do exactly what you just said. But what was the first thing we were supposed to try when we were trying to find the limits? What's the first method we do? Perfect. Perfect. Yep. Now, if this was a regular 1, we couldn't plug in 1 because it would be 1 over 1 minus 1, which would be 1 over 0. But 1 minus isn't 1. It's actually a tiny bit smaller than 1. It's like 0.999999. Okay? So we're actually going to plug it in. So 1 over 1 minus 1. Well, the top number is a 1. Normal number. Matthew Bai. What do I get on the bottom if I do 1 minus 1? Correct? Is it positive or negative? Perfect. Because 1 minus in your head is like 0.99999, whatever. It's a tiny bit smaller than 1. You subtract 1 and you get a negative small answer. If you want to write it that way, you can. 0 minus is the correct way to write it. If it helps you, negative small number. I don't know what's going to help you more. The fact is you have to know it's negative, and it's super tiny. So 1 over a tiny number is infinity. Negative would make it negative infinity. So without us looking at a graph, we know that on the left-hand side of this vertical asymptote, it's pointing down. Now you could probably see why I thought it might be a good idea to do this today rather than trying to rush through it tomorrow. Because these are weird. They're not normal. Does somebody, feel free to ask questions away here. Like, do you have a question on something? Go ahead. Yep. Yes. Sorry, I should have written it up there. Correct. Do you want me to do one other one together before I have you try a couple? Sure, I'll do that. I'll take the same one we did, but I'll expand. Oh, no, you know what? I'll do minus. I'll do minus so that it really is exactly like what we just did. Similar equation. Eric. Okay, Eric, can you guide me through this one, you think? Otherwise, I'll help you out if you want some help. That's perfect. Here, I'll just write down what you kind of just said. That looks like some sort of weird emoji now that I wrote it all out. Good. It's not. So 0 minus, good reasoning though. It's very good reasoning so far. So 0 minus is a negative number. Like to the left of 0 would make it like negative small. Squaring that would make it positive, but still small. So it's negative 1 over 0 plus. So very, very good so far. Do you think you know the final answer? Perfect, because the negative on the top makes the answer negative. The 1 over a small number is infinity. The negative on the top makes it negative infinity. Very good. Very good. Well, I'm going to put three questions up for you guys. I'll leave this one as an example. I'll put 3 questions up. Why don't you guys take a couple of minutes to see if you can do them? And then this is all we actually have planned for today, so we'll be done after this. So find the limit of 3 over x as x approaches 0 plus the limit of 1 over tangent of x as x approaches 0 minus. And then the last one, let's make it a 2-sided limit on the last one. The limit as x approaches 0, 1 over tangent squared x. Okay. You guys take a couple minutes, see if you can figure those out. Yes, Caleb?
Cyber's very happy.
Oh, good. Oh, yeah, the window?
She's sitting on the stop moving window, so.
Good, good, good. Let's put, I'm not expecting you to be done, but I wanted to give you some advance notice if you wanted to ask somebody else for help. Let's put Julia in charge of the pink one, Kelly in charge of the purple one. Ben, do you want to be in charge of the green one? Okay, the guidance I'll give you on the green one is that you have to split it up into 2 problems. You have to do from the left and from the right. And if those 2 answers match, then that's the limit answer. There's 2 ways. One way is if you can visualize the graph of tangent of x in your head. So I guess that also goes to Kelly on the purple one. So you can either visualize the graph of tangent of x in your head, or you can kind of think of the quadrants where tangent is positive in quadrants 1 and I should know this. Is it 1 and 2? And I believe it's negative in 3 and 4. No, tangent is positive in 1 and 3 and negative in 2 and 4. Either way, I'm going to guess most people would picture tangent, the graph of tangent of x in their head. I can draw a little sketch of it if you don't know what that looks like. So the little sketch of tangent is tangent looks like that, kind of like an S. Isabella, I think you're trying to ask me something, but nothing's coming through. It's just a weird noise. You can type it in the chat if you're trying to ask me something. Let's see. I don't even remember who I called on for the pink one now. Was it Julia? Or, do you want me to help you at all, or do you think you got it? Okay. Okay. How'd you get that? Absolutely perfect. Absolutely perfect. So the 3 is the part that I thought might throw some people off. I didn't know if somebody would try to write 3 infinity or something like that. So it doesn't matter if the top number is a 1, a 3, a 10, a 500. It's just the fact that the top number is that much bigger than the bottom number. So the bottom number would have to be added an infinite number of times to get into 3. Does the 0 minus mean progressively smaller? Yes. Yes, that's one way you could think of 0 minus. It's technically on the left of 0, but the left of 0 is negative. So 0 minus can be thought of as the smallest negative as well. The reason I even mention that, Isabella, say you have 2 minus. 2 minus doesn't mean it's negative. It just means it's 1.999. 0 minus is negative only because the left of 0 is negative. Okay, good. Good with the first one here. Does anybody want me to answer any kind of questions on the one in pink? Okay. Purple. Kelly? I think I called on you for the purple one. Okay. So 1 over tangent 0 minus. Yep, you're good. So if I picture this, I don't know why I drew so much on there. Oh no, I erased too much. If you picture the graph of tangent in your head, tangent of 0 is 0. To the left of it would be right there, which would be a very small negative number like you said. So it's 1 over 0 minus, which is negative infinity. Yep, good. Very good. Okay, Ben, so building on that. Ooh, bad infinity. Ooh. Okay, did you get these two first? Okay, so if I'm asking you to find a two-sided limit, I have to find the limit from the left and from the right. If the limit from the left and from the right is the same, then that's the answer that goes right here. If the limit from the left and from the right are different, then we would say no limit. So if you had been asked a one-sided limit, that's two, these are the answers down here. But two-sided limit means you have to compare both sides. The one on the left is negative infinity. I don't know if I could squish it any better. So when you say they're both infinity, did you just mean that they both had an infinity in the answer? Oh, you're saying why is this different than previous days? Oh, all right, that one. I'll do my best. Okay. Up to this point, the only way that we had a limit answer, exactly like you said, was if both sides were the exact same. So, limit from the left, limit from the right. Oh, crap. Was yours squared, Ben? Oh! Oh, yeah. No, I forgot yours was squared. I apologize. I forgot yours was squared. You're correct. You're correct. The square definitely does affect it. So if you have 0 minus on the bottom, when you square that, it becomes positive. So both of these are correct. Both of these are positive infinity. No. Yeah. It's just as easy for me to make mistakes as you guys, especially when I talk. Trying to talk and explain things at the same time as doing stuff is so much harder than it should be for me. No, you absolutely were correct. Squared is a big deal there. Okay, so try and explain this one again. So if you had a hole, that didn't affect the limit. Where it did get affected the most was like when we had something that was at 2 different heights. Something like this. So if we would say that there was a limit, if we asked about the limit right here, well then this was no limit because the limit from the left and the right were different. Okay? The only difference today best way to explain it. Infinity isn't an actual answer. Infinity still technically is no limit because infinity is not a real number. Okay? So if we're asked to find the two-sided limit on this one, then we would say it's infinity because the left and the right both were infinity. Now, if I'm like reading this answer that somebody gives me, if they're answering infinity, in my mind that tells me that there technically isn't a limit, but the fact that it says infinity tells me that it's going upwards. Because a limit has to settle on a value. To have an actual limit, it has to settle on a value. And if your graph is going straight up exponentially, it's not settling on a value. So, if we are answering infinity, it still means no limit. Basically, this is just a more detailed no limit answer. I don't know if that's kind of what you were somewhat trying to ask about, Caden. That help a little bit? Gotcha. It's just a more descriptive way of answering it. So, like usually when we do these limits, like the information stands for something. And so if your information stands for something, you want the most descriptive answer you can get. So, like a no limit over here is flat out no limit because the answers are totally different. And infinity is still no limit, but it's just a more descriptive no limit. So if this stands for something like how fast your blood absorbs a certain medication, an infinity would be. So Caitlin, it would be not fully correct. So I would. If you want to write doesn't exist, I'm fine with that. But you still have to have the infinity with it. So if you only answered it does not exist, you'd get half credit. Only because the purpose of us answering infinity means you know what happens to the function. But you answering doesn't exist means that you understand it's still doesn't have an answer. Now, you don't necessarily actually have to worry about what to answer most of the time, because on the AP test, these are traditionally all multiple choice. So in the multiple choice answer, it has both. This traditionally is not going to be a free response answer on the AP test. And I can't remember if I made it to multiple choice or not on my chapter test. So it probably won't even come up that you need to worry about it. Okay, let me be done. Let me stop the recording at least.